we need to discuss determining the equation of a trigonometric function by looking at its graph. So here we have the parent functions for sine and cosine, and we have all of the parameters that we need to sort of find in order to write the equation. So we need to determine what A is, which is the amplitude. We need to determine B, which impacts the period of the function. We need to determine what C is, which corresponds to vertical translation. And then we need to know what D is, which corresponds to horizontal translation. Now, many times you're going to have directions in a problem, which will help you stay on track. But you could write a sine equation for this graph as well as a cosine equation for the graph. So many times a problem is going to tell you write it in the form of sine or write it, using cosine. So just pay attention to those. All right. So I guess we can go ahead and start from the top and, work our way down. Let's start with how to determine the amplitude of a trigonometric function. So amplitude corresponds to the ridges and troughs that we have going on with this function. So the distance from the highest peak to the lowest valley, all right? And this distance would correspond to our A, all right? So again, what we are looking for A is going to be the distance from this peak here to this lowest point there. That distance is going to help us determine what A is, all right? So whatever A is, if we take this, so this distance will be equal to, and let me move that up, this distance would be equal to 2 multiplied by the absolute value of that A. All right, so what is this distance here? Well, this height here corresponds to 3.5, and this point there corresponds to 0.5. So then this distance would be equal to 3.5 minus 0.5, or it's a distance of 3. All right, so we can find our A. We can find our A by substituting this 3 into this sort of arrangement that we have here. All right, so basically we'd have 3 equals 2 times the absolute value of A, or that the absolute value of A is equal to 3 over 2, or 3/2. All right, so this helps us determine what A is. All right, so A being 3/2. Now, something to keep in mind is that A can be positive or negative depending on how you decide to write your equation. For this particular example, we're just going to focus on A being positive. We're not going to even think about it being negative. All right, so we've determined what A is. A is 3/2. This is a good look for us. All right, so let's document what we have over here. Let's A is going to be, all right. So now moving on down our list, we need to determine B, which impacts the period of our function. So something that you'll need to determine B will be this sort of arrangement that we have for period of the function. So the period of a trig function can be represented as omega equals 2 pi over b. All right. Now we can get the period from the graph but we'll need this equation in order to determine what b is. All right, so let's look at the graph and see if we can't determine the period. Now, the period of a trigonometric function is the distance on the x-axis that is required before it makes a complete oscillation. So it needs to start at a point and it needs to return to a point. Now we can readily see in front of us that this distance for it to start at 0.5 and end at 0.5 is going to take pi units in distance on the x-axis. This would even work even if we moved out a little bit and we compared, where cosine typically starts up at, well, it would normally be 1, right? So the highest point in the range and how much distance it takes to get back to that highest point in the range. But luckily here, we can just see in order for us to get to the same point in the range, it takes us, again, pi units of distance on the x-axis. So using that information, we can substitute that into this function that we have, or this equation we have for the period of a function. We can say, hey, it takes pi units to travel a complete oscillation. We can determine b by solving for b. Multiply both sides by b. This would cause b to cancel on the right-hand side. Then we can isolate b by dividing both sides by pi, and lo and behold, b is going to be equal to 2. So updating our information up here, the period of our function, b equals 2. So again, just a quick recap. You just need to determine the amount of distance it takes on the x-axis for that particular point in the range to occur again. All right. So making good headway here. We have 2 of 4. We have 2 of 4 of our parameters here, and now we just need to somehow determine what we have going on for our vertical translation. So now vertical translation corresponds to the amount that the graph has been displaced up or down. All right. In this case, you can kind of see it's been displaced up, but we need to determine how much it's been displaced. So something that's going to help us is to find the midpoint between the highest value and the lowest value. And we can use a little bit of information from the distance that we have there. We're going to take 3.5 minus 5, but then the midpoint formula is going to require us to divide that by 2. So the midpoint of the range will be 3.5 plus 0.5. That's going to give us 4. And 4 divided by 2 is equal to 2. Yes, that is the midpoint I was looking for. So the halfway point for our graph is going to be along this dotted yellow line here. All right. And this halfway point will help us determine how much it's been shifted up. So typically the halfway point will occur here at 0. So whether you start with cosine at 1, and then you're going to move to the halfway point around a oscillation of your trigonometric function. So it would start at 1. It would go to 0, down to -1, back to 0, back to 1. So we need to find out how far from 0 this thing has been displaced. So typically, the halfway point would be here at 0, but lo and behold, a halfway point has been shifted 2 units up. All right, because again, these are our halfway points on our unit circle. So halfway to -1, halfway back to positive 1. All right. So this has been shifted up 2. That means that our C is going to be equal to 2. This has been displaced 2 units up. All right. So let's get that information over here. C is also equal to 2. Again, you're looking for that midpoint of your graph here. Finally, we need the horizontal translation. Now, this again is a little more, counterintuitive than the others. But what we're going to focus on is just going to be, all right, we want our D to be positive. So what we have here is negative. So we're just going to assume that there is a shift to the right, and we need to determine how many units to the right we're shifting. If we're thinking about our cosine will help us out quite a bit. We just really look at where cosine typically starts. Cosine typically starts here at 1, or at the highest point in the range. So what is that distance where cosine has been shifted? If I draw a dotted line downward, I would see that this function, if we're thinking about cosine, has been shifted pi over 2 units right. Now, if we were thinking about sine, so maybe the problem asks you for sine, sine typically starts off in the sort of halfway point. So 0 typically, but since this function has been translated 2 units up, the halfway point will be now 2 in the range. So sine typically starts here. So if we were thinking about sine, we would say this function, and again, this is for cosine up here. But if we were talking about sine, we could say that sine has been shifted pi over 4 units right. And this is for sine. So either way, we can write the equation based on this. But again, your problem is going to typically give you what trig function it wants you to write it in. So we kind of have everything that we need, and now we just need to plug things in. So over here, we'll write both of them. So we'll make something for cosine and sine. So as far as cosine, this is going to be D is equal to pi over 2. And then for sine, D is equal to pi over 4. So it looks like we're ready to write our equations and just substituting our stuff in. All right, so let's do cosine first. Y equals, A is going to be the same. We're just going to assume A is positive this time. A cosine 2 times x minus pi over 2 plus 2. Let's simplify everything. That means distributing this through. 3/2 cosine of 2x minus pi plus 2. For sine, y equals 3/2 sine of 2 times, x minus pi over 4, this is brackets here, plus 2. Simplifying this, we're going to wind up with y equals 3/2 sine of 2x minus pi over 2 plus 2. So just a quick recap. We needed the parameters, the 4 parameters of a trigonometric function in order to graph it. A, B, C, and D. A representing the amplitude. B representing parameter of the period of the function. C is represents vertical translation, and D represents horizontal translation. Feel free to reach out with any questions and or comments. Peace.